Hey, this is Sri. Welcome to Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. Hey, Will, how's it going?
Hey, Sri, how's it going? It's going all right over here. How's it going with you?
Nice. Pretty good, pretty good. I like your t-shirt. Nice throwback.
Yes. All I have, my only wardrobe are failed startups. So
Nice.
pretty soon nobody will know like what these brands are after a while.
Cool. What you have any interesting things beverages wise?
Yeah, so I have carrot juice, organic. This.
Nice.
So what is this? Evolution Fresh. Wow. Organic carrot citrus radiance. Carrot pineapple, blah, blah, blah. But it should be good.
Very cool. Much healthier than what I'm drinking, which is this Citizen cider. It's a cider that is supposed to taste like beer. So it does. It looks like this. Kind of looks like a very watery beer. I don't know. We'll see.
Lemonade. Yeah, and I guess I got more the Mikan that I was drinking last time. Actually, I should actually take this out. I think I reserved it. So anyways, no worries. So what are we talking about this week?
Well, we are talking about functional programming, and specifically about functional programming infiltrating the mainstream. So I think functional programming, as long as I can remember, was this exotic concept in these exotic languages like Lisp that were used, Haskell, things like that, which were used by, I don't know, like wizards, I guess.
Graybeards, right?
Yeah,
right.
graybeards. And so there were those languages for those people, and it was kind of a scary time. And then there were languages for the sort of working man. And I think over time, those two concepts have sort of merged in that people are taking piece by piece the concepts from functional programming and bringing them into the mainstream. And we're seeing that in a lot of popular libraries like React, which we discussed last time. So yeah, it should be interesting to kind of go through and see what the progress has been so far, and then also where it can go further and where it can take us into the future.
Right. Either you die in imperative programmer, or you see yourself turn into a functional programmer.
Right. I guess, or maybe from the flip side, if you're a functional programmer, eventually all of your talking points that you use to convince people to use your language are going to be stolen by JavaScript, and you might as well become a JavaScript dev.
Right. Exactly. Yeah, to the point, I think it's something that I've seen slowly as well. It's taken years, but there are a lot of concepts from pure functional programming that have been borrowed into either the new hot and hip language that are coming out for a particular platform, or it gets subsumed into very popular mainstream programming languages. Do we need to define what functional programming is for people, or do you feel like most people that would even tune into us would already know what it is?
I feel like most people would know.
Okay.
Or we can go after it. Okay, well, let's take a stab at it. Actually, you want to take a stab at
like what is functional programming?
What is functional programming, or at least what are the concepts we are alluding to?
Right. And so I think the first time that I started learning about functional programming, the first thing that was introduced to me was that the variables are effectively constants. They don't change, and that the methods only operate on the inputs. And so for the same input, you would always get the same outputs. Everything would be functions, much in the same way that math functions, their output is only a function of the input. And so I was surprised that this would be a thing, because if you can't change variables, I thought, how do you even get anything done? And so as I dove into it, I figured out that functional programming is a way to constrain the programmer in a very specific way to lessen the cognitive load of building a system. Everybody argues for the most powerful programming language they can get their hands on, but I'm starting to come around to the sense that if it's completely unconstrained, yes, you have a lot of expressivity and power, but you can also build things that you just eventually just don't understand at all.
Yeah, I think that's a great way to capture what the benefits of functional programming are. And there are a bunch of tactics I think each language might use to ultimately achieve that goal. I think at the core, it is this idea that you build your programs out of these functions that take inputs and have predictable outputs. And like you mentioned, a very common tactic that's used is the immutability of data. You instead make a copy of it, or you use some type of mutator functions which return a copy that's mutated in a particular way. So there's that idea. I think there's the idea that I first heard of in Clojure called referential transparency, which is the idea that you can effectively, anywhere that you see a variable, you can take the current value of that variable and replace it, almost kind of find and replace it in the text, and the program should run exactly the same. So because everything is a value and it's kind of a stateless value, you don't have to worry about these like hidden state, or like the source code is written. If you know the source code is written and you know the value of a variable at a given time, the execution should be predictable.
And I've heard that mostly in reference to the distributed systems, because distributed stuff is hard, because the things that are intuitive to us, like time being the same everywhere, some of these assumptions don't hold true anymore. And so in order to build systems that are reliable and understandable, if you are able to leverage referential transparency, that means that you don't have to take into account any hidden state. If you see stuff going into a function, then you know for sure like what's coming out every time, no matter when or what happens. You don't have to take into account any side effects that are going on.
Yeah, and I think that makes things like testing a lot easier, because a lot of testing, a lot of the complexity is injecting the right dependencies, mocking the right things. So basically faking the state of the world so that you can have a predictable test run. And things like referential transparency save all that kind of headache.
Yeah, the saying goes like, you want to test the banana, but you have to instantiate the gorilla holding the banana, and then the jungle that's holding the gorilla, and so on. And before long, you have to like mock out the entire world just because you want to test the banana. And so with functional programming and this kind of referential transparency, that's what we mean, that it makes the test easier. Because if you want to test the banana, you just have to test the inputs to the banana, not anything else that's using it.
Yes. Yeah. So I don't know, what are the concepts that you've seen that are being popularized from functional programming that you wouldn't expect?
So in the last couple of years, I've been doing a lot of web dev, and I see a lot of influence on front-end programming. There is a state management library called Redux for React programming. It's actually based off of a programming language called Elm, which is a pure functional programming language for the front end. And they came up with what they coined as the Elm Architecture. And it's a way to structure front end apps so that it's much easier to reason about the effects of a user input.
Yeah. Redux is super influenced by the Elm architecture, and I think it actually basically takes the idea like wholesale. Maybe it's evolved since then, but the core insight was in Elm all along, and they brought it to JavaScript almost in its entirety. And that's a trend that I've seen happening in the React ecosystem consistently. I think we alluded to it in the last episode, definitely, but the idea that React, when it first came out, started with these class-based components, and increasingly those are falling out of favor, so that you don't have to write these lifecycle methods and all this object-oriented type of code. And now the best practice is just to write, stateless components, and hooks, like we mentioned, go a long way into making that super easy. And so I think that they're taking a lot of pages out of the functional programming book, and we're seeing the benefits of that. So front-end web apps used to be sort of this huge mess, and you'd always have to worry about syncing the right things and messing up some state somewhere, whether that's the DOM or whether that's the internal state of your application. And it seems like that whole class of problems is kind of dissipated.
Yeah. Like there's other problems now, obviously, right? But definitely like the kind of inconsistencies that you're talking about, like they generally should not appear. Now we have problems such as like re-rendering, or like when the app is re-rendering too much, or for like you have to work around the React system if it doesn't quite do what you expect, since it's more of a declarative API now. It really reminds me of an effect system that occur in pure functional programming languages. And so earlier I was alluding to, oh, if variables don't change, like how do you actually get anything done? If there are no side effects, like how do you do anything? Because like the very basic program that anybody learns in any language is to print hello world, right? And IO is effectively a side effect. So if that's not, like, how do you do anything? As a caveat to our listeners, most of my experience in pure functional programming languages is with Elm, and so I'll speak to that. And in Elm, you can't directly do side effects. You have to create commands to the runtime to perform a side effect for you. And so that's kind of the trick that pure functional languages, and I guess especially Elm, that use to keep everything pure functional so that they're still referentially transparent. And so in React, it's similar, where if you squint a little, all the use hooks, like use state, use effect, they're commands in which the implementation and handling of that command is embedded in the use hook itself. And so when you use it, that's when you're saying, I want to use it. And then what you do to handle that effect is declared in there.
Yeah. I haven't used hooks a ton, but I imagine that there are a lot of common hooks that I see. A few that I've seen in common libraries are hooks that get the state of the browser window for like media queries. That's a common thing that people want to query about the state of the world, or even things like whether the user agent is in dark mode or light mode, and using that to render the components differently, or change the CSS class on a component. And those are things that if you had to test them without if you had to test them without hooks, it would be pretty hard, because you would have to set up some test harness that either fakes the browser media query API, or fakes the light or dark mode setting. Whereas I imagine in hooks, I haven't actually written any hooks based tests, you could probably swap that out, right? You can keep your nice clean function and have a kind of test hook or something that returns the thing that you want.
Yeah, effectively, it's kind of like mocks built in, because a lot of times people use mocks because they don't want to end up testing the database connection, because you know that once you issue the SQL command correctly to the database, chances are it's going to do the right thing, right? And so that's, and for any number of reasons as well. And so having an effect system is effectively drawing that boundary between your system and whatever external system that there is.
Yeah. React is sort of leading the charge with the functional programming stuff. But I see it all over the place. Just basic JavaScript. Things like callbacks, which are all over the place, are basically like Lambda functions that get run, and people are now very comfortable with it. I remember when Node.js came out, that was probably the first time that the general programming community, meaning people who weren't front-end developers, were exposed to callbacks.
Yeah.
And so,
or even just passing functions, because passing functions is not nearly as natural in object-oriented programming languages for whatever reason, I guess. Like nowadays all OOP languages have methods as first-class functions, I believe, like most of the popular ones, but it's not a mechanisms that you leverage, I guess, because most of the design patterns don't default to that due to the stories that we tell ourselves, I guess, as in terms of best practices. But yeah, it wasn't until JavaScript that I saw the extensive use of first-class functions.
Yeah, I think that was the first time that I had seen it too. It was pretty bad in the early days because people were just trying to figure out how to use these callback functions. I know there were lots of jokes in the early Node.js days about how any sufficiently long like Node.js code would sort of look like this. Because you would have like callback and then nest into another callback, nested into another callback, and eventually your indentation level would go completely nuts. And it's been interesting to see the community figure out ways around that. So now the common way to deal with asynchronous callbacks is promises, which I think are another, is similar to some other functional programming concepts like error monads or promise. There should be a bingo.
Right. Like, how long were we going to go into this podcast before mentioning monads? So yeah. And so we'll talk about that a little bit. I'm sure you have your opinions about monads, but yes, actually, I was gonna say, like, nowadays I depend mostly on async await. Like it took a while for them to actually have the language level construct so that you can do asynchronous, and JavaScript is by default asynchronous, and then you have async await to kind of turn into more synchronized looking calls. So people still use promises, but I personally like the async await a lot more for doing that sort of stuff.
That's true. I think that async await has changed things a lot. Although, does async await still have the problem that now your functions are different colors? So you have async functions and non-async functions, and you have to distinguish the two.
Yes, and so you do get some oddities. For example, in going back to React, the callback for use effect has to be a synchronous function, even if the work that you do is asynchronous. And so the workaround is that inside of the synchronous callback for use effect, you declare another async function inside of it and just execute it immediately.
Callback call. All right. Yeah. So, I mean, at any rate, I think the JavaScript community has dealt with asynchronous programming with increasing amounts of maturity, maybe rediscovering a lot of the concepts that the functional programming community has already been using. Yeah.
Like in Haskell, there's like a let, and I only know Haskell minimally, but like in order to avoid some of these callback hell sort of stuff, they have syntactic sugar for it. But then as going back to monads, then have you seen monads? I mean, making it over to mainstream programming languages?
Yeah, I think that the closest I've seen is promises. So if you squint, a promise implements the main like monad things. Like, so a monad is a type class which has like, a few requirements. Like you have to implement like a one or two like functions.
Do we need to back up a little here?
We risk
Risk,
being
yes.
those like stupid, like a monad is a burrito.
Right. Yes. So I guess my crack at this, the short version is that a monad solves a problem that you would see only if you used pure functional programming languages, first and foremost. And so if you don't have the programming environment that motivates those problems, then it's going to be hard to understand why anybody would use monads in the first place. And so I guess to say off the bat, that's why a lot of these tutorials on monads are so incomprehensible, because they don't talk about like what the concrete problem that motivates this is in the first place. But I think the other thing that people find really neat about it is it turns out that monads are a design pattern. And so the design pattern for monads, if you make sure that they have these three simple interfaces, turns out that you can solve a whole bunch of other problems as well. And so that's why a lot of people, once they get it, they get excited about it. And so so then that's why there's so much hubbub about monads. And even though what I said earlier, that the motivation for monads is most apparent in pure functional programming languages, that's not to say that you can't solve other specific problems with it. And so that's why you see them making it over to mainstream programming languages in the guise of, say, promises. I was going to mention option chaining in like TypeScript. I think Swift and Kotlin have it now as well, where like sometimes like if you have an object that has a secondary property, right? And so if you're not sure whether the object itself exists or not, then you might put an if statement. So if foo exists, then call foo.bar. And so option chaining is where you put a question mark from the dot. So it would be foo question mark dot bar. And I believe that that's like a hidden version of a monad. Is that correct?
Yeah, I think so in some way. Yeah, because basically there's like the optional monad. An optional monad is just a wrapper that says there could be a value here, or there's not a value here.
Mhm.
And if there is a value here, then you do one thing. And if there's not a value here, then you do another thing.
Right.
And that's basically what this option chaining is. Basically, you say, well, if there is a value here, then continue to access its other nested properties. And if there is no value here, then basically just short circuit and don't try to access it.
Right. And so at the end of the day, for the last 5 minutes, it's just to say that I originally thought that maybe monads didn't make it over despite all the hubbub that people say, but it's made it over in very specific forms that people don't immediately recognize as monads.
Yeah, for sure. Yeah.
Yeah. And then I guess the final place that I want to mention real quick about like where I see functional stuff is in the immutable data structures, and most notably in like version control and cryptocurrencies. And so they adopt it for slightly different reasons, but they're making it more palatable to everyday programmers that this is immutable data structures is like a valid thing and you do it for very specific reasons.
Yeah, that's pretty interesting as well. There are very obvious advantages to that, right?
Yeah. So you get a history and you get the provenance and auditability, and because like data storage is relatively cheap nowadays compared to before, I mean, we can actually do it. And actually if for those of you that would be interested, Rich Hickey The guy that invented Clojure, he has a talk called The Value of Values, which I thought was a really good introduction to immutable data structures as a kind of like the why you want to do that. We won't get into that here, but you can go watch that. So like we kind of went through a laundry list of things that we've seen, and hopefully people are still with us. And so where do we go from here? Like what's it let us do? What's the new stuff that we can build as a result of adopting this sort of thing?
Yeah, I mean, one really obvious advantage is the reduction in complexity. So if you have very, very complex patterns, design patterns with side effects, and it's very hard to reason about, you need a lot of people in order to do anything simple. And so I think just from a pure developer productivity perspective, I mentioned it in the last episode as well, I think that one person who is using React and using the best practices that today is able to be significantly more productive than an entire team of developers who were building a front end back in the jQuery days. I don't have any quantitative data that proves this out, but just the idea that like looking at the kinds of apps that are posted on Product Hunt or Indie Hackers, they're very, very complex applications that are full of state and full of interaction. And I don't remember seeing individual programmers being able to produce that level of high quality applications.
Like did teams of programmers 10 years ago, could they achieve like apps with the same level of complexity using jQuery? Or was
to be honest,
or was JavaScript just still not good enough then to kind of do something like that?
I mean, definitely there were complicated.
No, that right. Yeah. Gmail existed, and I think Etherpad, but yeah, like Etherpad was written by this guy was really, really good. Like he implemented operational transforms on top of like wrestling with JavaScript before there was all this React stuff. So kudos to him. But yeah, like I guess Google Wave and Gmail, those are examples, and they probably had pretty big teams to do that sort of stuff in the very beginning.
Yeah,
but then
exactly.
Gmail in the beginning, I thought their team was relatively small in the very beginning. No,
it's possible that it was small, but I would say that a small team at Google is still significantly larger than anything that you see outside.
But I get what you're saying. Like, short of, I guess, the exception, it's within the reach of more teams and smaller teams to build apps of higher complexity. And at the very least, we can see that as evidenced by the type of apps that are deployed nowadays. So if anything, at a high level, I would buy that.
So anyway, so I think that developer productivity is probably through the roof compared to any time in history. And I think that a lot of that does in fact come from the gains in functional programming concepts coming into common languages. You see it even now with things like Kotlin, which is relatively conservative in what kind of new concepts it incorporates, but it incorporates just enough things like option chaining and lambdas and things like that, that it's a significant boost in productivity over Java for building Android apps. And Google is just like, just use Kotlin, like forget Java, just use Kotlin. And so like in a span of maybe 2 or 3 years, it went from being like a toy language that was developed by a European IDE company to being the flagship programming language for the most popular operating system in the world.
Yeah, I mean, no joke, 2 to 3 years ish is extremely quick for a programming language. Yeah. Are there others that like what are the systems that are most amenable to functional programming? Like what sort of systems would naturally be a good fit for this. Like the thing that came to mind immediately was distributed systems. But yeah, I want to say generally, perhaps too broadly, any system that maintains state. And I guess I'm thinking about the paper that we mentioned last time with Out of the Tar Pit, which is a paper about where the hard part of programming comes from. And the authors of the paper said one of the hard things about engineering and development is getting the system to maintain the correct state. Like state is the root of a lot of bugs. And so what we can do to get maintainable systems is to compartmentalize the side effects and the state manipulation code so that it's all in one place rather than littered everywhere. And as much as we can, have functional utilities that operate on this, on the data that comes in and out of the system. And then whatever side effects that you need to do, like you delegate that to one part of the code. It definitely reminds me of the hexagonal architecture, in which they try to push writes to the database into one part of that hexagonal stack, and then try to leave everything else more functional.
Yeah, that makes sense. Like a functional core, and then you isolate your side effects. Another thing that comes to mind is actually data science. So a common complaint about notebooks, especially Jupyter notebooks, which is the kind of de facto tool that people use for data science, is that there's a lot of hidden state. Just very simply, the order in which you run the cells is your hidden state. And so if you run the cells in like one particular order, you'll get one kind of result.
Yeah, or it just won't run at all, right? And so most people just blow away the entire hidden state and rerun everything from the beginning and then go out to lunch, right? Where it doesn't actually have to be that way. I think Observables is another notebook. They generate a DAG, I believe, of the different cells so that they can only rerun the specific things that they need to, I believe.
Yeah, exactly. I think that they make use of a DAG and maybe something similar to this React reconciler that we were talking about, actually. But at any rate, I think the idea is that, again, going back to this referential transparency, the output of the cell, you can basically pretend like that is its value everywhere on every cell that depends on it.
Yeah, and rather than just some sort of hidden state, because like you might have changed something up in a cell that affected something. And so when you run it a second time, you expect it to work, but it doesn't because you happen to run some other cell higher up and it changed some hidden state that you were unaware of.
Yeah, exactly. You can basically assume that once you've evaluated something, you can rely on its value. And you also know when to reevaluate something because you say, well, all the things that, one of the things that it depends on has changed. And so I know that I need to reevaluate it and I can cache its value thereafter. So I think that's a very powerful tool. Observable notebooks are super, super fun. I don't know if you've made one before, but it's a game changer just in terms of it feels like magic, basically, because you don't have to think about running the cells as much. You just sort of set up the dependencies between them, and it
feels more like a spreadsheet than it does like a REPL or some programming language, right?
Yeah, exactly. So you brought up spreadsheets. That leads me to the next thing. So I've been thinking a lot about what are the second and third order effects. Right? So okay, great. Like we've learned all these secrets of the wise graybeards and taken them, and now life for programmers is better. But so what? Right? Like, what's going to happen in the world? And I think that as you reduce the complexity of programming, it becomes more and more approachable to the average person. I
Mhm.
think that spreadsheets are probably the number one, like, most understood kind of programming
Yeah,
language or
yeah,
programming runtime in the
yeah.
world.
Excel is the most popular programming runtime in the world by far, I think.
Yeah, and people, of course, people learn anything out of necessity, and definitely people learn Excel out of necessity. But I think that people somehow have an intuitive grasp of, like, Excel in a way that if you just take the same person who programs in Excel and you say, here's Python, they'll be like, oh, I don't know about this. But, like, they were programming in Excel all along, right? And I think that the the diff there is that things like Excel, where again, cells are basically referentially transparent. Once they're evaluated to a
Mhm.
value, their
Yeah.
value propagates through the rest of the cells that depend on them.
As
It makes,
far as maybe an aside is that I think Excel can request stuff externally, but let's just put an asterisk on that and say yes. Basically, like it depends on other cells.
yeah. So you can request stuff externally, but once it's fetched that value, you can basically
Mm,
pretend like that value is just cut and
it's
paste.
immutable. Yeah, yeah, yeah.
It's immutable and used everywhere else in the system. And I think
Mhm.
that makes it very, very easy to understand what's happening. Of course, it has terrible affordances in that you can't really picture the whole implicit DAG of what's going on in an Excel
Right. It's a very
spreadsheet.
data centric view rather than a program centric view.
Yeah, exactly. But that aside, I think that it makes sense to people at some intuitive level. And so I think the promise of functional programming is that if you incorporate these concepts into more and more tools, you can actually bring more and more people into the fold of writing some type of code, whether they know it or not.
Yeah, I want to say that to career programmers that got their start with imperative programming, it would seem like what you're saying is backwards. And because like when you grew up with imperative and you move to functional, your brain has to like readjust, right? Whereas in I remember reading a paper about how to teach computer science to like undergrads and freshmen. One of the most confusing things to them is variable assignment.
Yeah,
And it's like a equals 3 and then all of a sudden a equals 4, and so like it just seems really confusing because like the state of the thing is not just what you see on the page. You have to like actually execute it in your head and hold like variables in your head, right? but
yeah,
like but like what most people by default know about variables is what they learn from math, which is like if you say a equals 2, a always equals 2, right? And
yeah,
so the people that learn programming functional first actually found it much easier to pick up than if they were going through the imperative route. It's just that most programmers in the world, if you're a programmer at all, you went through that imperative route, which like all of us are brain damaged in that way, I guess you could say, and
yeah.
and the functional scene. So I would say that in support of what you're saying, I can believe that like if people got started with functional programming concepts, they would definitely pick it up a lot faster than if they had to kind of pick up imperative things, is my sense.
Yeah, so I was teaching my fiance's younger sister Java. She was taking an intro to programming class, which is taught in Java.
And you
And
learned like all the things that you thought were like really, really like how okay, I guess you have to explain this, right?
yeah, no, it was horrible. I was like, I'm so sorry. Like the state of this industry, or at least the state of the tools of this industry is just so horrendous. Like there's no excuse for any of this. But it
Even
was
just setting up the dev environment, you're just like, I'm sorry, like I thought this was like easy just because like, or like at some point I thought it was hard, but like I figured it out. But like when I'm like dictating this stuff to you, like it's obvious it's a terrible experience, right?
Yeah, 100%. I'm like, just don't worry about this for now. This is just meaningless. This is just how it is, but it shouldn't be this way. But it was interesting watching her kind of get a grasp on these concepts. And you're 100% right. So when she was writing some code, she would use the kind of mathematical definition of equality. So she'd say like x is equal to something. And then if she wanted to multiply it by 2, she would say x2 is equal to 2 times x. And then like mutated in some other third operation, she'd write x3 is equal to something, some function of x2. And I was like, you don't have to do that. You can just reuse the value x. And she was like, why? I said x is equal to this thing already. And I was like, okay, you're actually like onto something here.
Yeah, well, so I want to say that's a historic accident because like early computers just did not have a lot of memory, right? And I guess the von Neumann architecture also helps it like push people in that way where everything is updated in place. And so I guess once again, referring to Rich Hickey's like value of values, you can see that like the way that we think about the world semantically is that things are values. And so you wouldn't like update things in place because like a lot of times we refer to the place of something in reference to the actual value. But if like the value goes away, like databases, for example, like we reference the place and we update it in place rather than the actual value, which like once it's set, it's always set, right? And that has its advantages.
Yeah, totally.
Which is
so
yeah. Well,
yeah,
which is how like your protege was understanding the world to be, right? So
yeah, exactly. And so, watching that, I think that if you simplify the world so that you don't really have to keep track of the set of mutations that you've done to a variable, because it makes things kind of hard to reason about.
Because you have to hold that in your head, and when you have more of them, you're effectively playing computer, and that's what a lot of programmers are. We are an extra computer outside of the computer so that we do things in our heads and try to match the computer in front of us to do what we think is going on in our heads.
Yeah, totally. So I mean, that's why I guess programmers get paid big bucks, is because it's simulating a computer in your head is hard work. And so I see some inklings of this idea that you can democratize programming by simplifying a lot of these assumptions. In iOS, there is a now first-party app called Shortcuts, which allows you to build these chains of automations. So you say, if this condition is met, then like do X, Y, Z. And these things are not quite what we're talking about with functional programming because they can have side effects. They do have mutable variables and things like that. But the structure that they lend themselves to is very much this sort of functional idea. Each block of a shortcut has inputs. It has known inputs, it has known outputs. And so it makes it a little easier actually to understand what's going on, and then also how to compose them to have a higher order sort of workflow. And so things like shortcuts are a way in which if you constrain the things that you can do with programming, you can actually increase the output, the pure volume of software that's produced, just by making it simpler and easier to reason about.
So then we had talked about functional programming in terms of what it buys us. And it seems like one of the main advantages is that it reduces the complexity of the systems that we write so that we can actually reason about it and fit it in our heads. One of the trends that I see recently is the companies that tout observability in our stack, and mainly they're referring to like production systems where sometimes things can be opaque. But recently I read an article about developer experience in which we should embrace the complexity of our systems by making them more observable. And so we should build more tools to help us manage this complexity, whether inherent or incidental, that we create for ourselves. And so effectively build thinking tools to help us manage this complexity. And while I'm all for thinking tools, on the other hand, for some reason, this doesn't quite sit right with me, because that means that if we are able to have tools to manage more complex programs, it seems doubtful to me that we'll use that power to reduce the complexity of the program so that we no longer need those tools. It seems like it would actually end up being the new normal, and then we would just make even greater complex programs, right, that we wouldn't have been able to build without these tools in the first place.
Yeah.
And it may get to a point where our programs are just not at all understandable by a person without the help of some of these tools. And so, like, for me, I use Vim partially because I don't want to use IDEs that help me do autocomplete, for the reason that I want to keep my program simple. Because if I can't keep that in my head, and the connections, that means like my components are not separated enough and modular enough. But if I have an IDE to help me autocomplete, like, it doesn't matter how I connected it up, like, I'll always have that recall. So I'll never actually feel the pain of a complex system that I am creating. And so do you see kind of the two dichotomy? And so, but on the other hand, like, you could argue that we're already there, because like people that design CPU chips, I'm pretty sure like no one person understands the entire chip. Like, we already have like computer assisted tools to help us design CPUs nowadays, and there's no way that we're going back to simplifying those problems so that they all fit in one person's head. And so maybe like I really should start embracing IDEs, and then maybe functional programming doesn't matter, because if we build these tools to help us manage these complexity, like, who cares where the hell state is? They could be littered all over the place. So like, do you get kind of like what I'm getting at? Do you?
Yeah, totally. I totally get what you're getting at. And I think it's a really, really fundamental sort of historical distinction, because we've been talking a lot about all of these concepts which are rooted in effectively Lisp, which was a programming language which is so simple that it could be described on a printed piece of paper. You can fully specify
with your hand, right? Yeah,
you can cover it with your hand. That's the whole. It's almost like a mathematical axiom in its simplicity, and from which you can build higher level constructs. But it strives for simplicity. It's rooted in simplicity. And there's this whole other branch of computing history which we haven't yet talked about, which is this object-oriented programming, which we've sort of poo-pooed. We've said, oh, object-oriented programming is, Java is a shitty language and is very complex and makes things hard, and functional programming is better. But object-oriented programming, if you kind of derive it and trace its history all the way back, is rooted in these ideas that come from systems like Smalltalk, which is this idea that the whole computing system, all the way from your language, your source code, to the running state of your program, to your operating system, all of that, the entirety of it is inseparable. So in Smalltalk, you don't have programs, you have basically workspaces or virtual machines, which include not only your source code, but also the current state, so all of your program state. And you can at any time inspect what your current program state is, and you can even mutate where your program state is. And you can, not only that, you can change the source code of the running program as it's running.
Yeah.
Right. And so I think that's sort of what you're alluding to, a little bit in that small talk or object-oriented program is very, very observable. And these days, we're kind of lacking that because we have these very, very complicated systems which are composed of microservices and databases and load balancers and all this AWS or cloud services. And so we don't really have a way to corral all of that and say that this is the boundary of our application, and everything within this we can actually inspect and query and be aware of. And so, I mean, I think there is a fundamental tension between these two concepts, because one, functional programming is saying make everything simple. You don't even try not to even have all of this complexity. And then object-oriented programming kind of is basically saying embrace the complexity and in fact make it readily available,
so queryable and whatnot. And I can see it both ways, honestly. And so I tend to be a clean programmer. And so like I try to make it understandable. I care a lot about like developer affordance and whatnot, but that sort of stuff takes time. And you don't always have time to kind of do that when like depends on where you work, obviously. But then and sometimes it doesn't matter because you throw it away, right? Or sometimes it doesn't matter because the startup fails. But if it's something where we are building tools to help us build more complex things, they may be more powerful, but I wonder if it's something where we're all in a joy clown car headed off the cliff, where eventually we'll get programs that we deploy that we really do not understand. And maybe it's already happened with like deep learning, but I don't know. You tell me, because since you work more in that end of things, and so maybe the cat's already out of the bag, and so that's why I'm wondering, like, does this functional programming stuff matter, and should we focus more on tools instead to help us wrestle with this complexity regardless of where it comes from? I think that's the thing I wrestle with.
I mean, so leave deep learning aside, that's a whole different clown car. So one clown car at a time. I think that in programming, there's this idea of reducible complexity and irreducible complexity. So reducible complexity is things that you can avoid, like you can simplify the architecture of your system so that the interfaces and things don't make it harder than necessary to describe your problem that you're trying to solve. But at some point, there's irreducible complexity. If you are solving a hard problem in the world that has many, many facets, interfaces with many, many things, no matter what kind of magic tooling you use, that complexity has to be somehow encoded into your system, right? If you have a banking system that has centuries of rules and things, edge cases that it has to handle. Right. I mean, you have to put that somewhere, right?
So unless your programming language can actually like go out and change the law, like submit a bill to change the law so that you can simplify your program, then that's considered irreducible.
Yeah, exactly. So unless it's the case that you can go out and change your problem space fundamentally, at some point, you're just going to have to accept that the world is complex. The ideas that you're manipulating are themselves complex. And so I think that these two things sound like they're in tension, right? Simplicity versus observability and embracing the complexity. But I think the idea is, in fact, that you should use functional programming or whatever tool to reduce your reducible complexity. And then when you're left with only your irreducible complexity, then you have no choice but to embrace that. This is the nature of life. This is the nature of your human birth. And you have to basically then figure out how to wrap your head around what this material existence is, right?
Yeah.
And so
Yeah. And so I think that that's probably right in the ideal case, but I'm afraid that the what ends up happening is people don't have time, so they just take whatever complexity regardless of whatever and use the tools. And so yeah, I
yeah.
mean, but that said, I think I don't think people are wrong when it comes to kind of embracing the complexity and help with tools, because like when I think about it, there's a lot of different things that we use already that we don't even know, no single human understands it, and so we already have to embrace it. And so, but
Yeah.
the thing that you're saying is just that even though we have those things, functional programming can still be useful in tamping down the complexity before we submit to our tools, basically. I find that like if you're able to move up a level, like the industry goes through a growing phase in which everything is imperative at that level first, and then they figure out how to make it either functional or declarative. And then once that problem is solved, they move up to the next level, but that next level is imperative. So for example, like in rendering on browsers, like that is figured out for us. And so for CSS, that's completely declarative, right? And so like we don't have to worry about like I don't know whatever the render loop for like whatever the browser is doing. But we find that having declarative language CSS without variables is constraining, so we make template languages for it. And then sometimes we like, oh, we need a way to generate these different templates, and so that kind of goes back to an imperative language, but at that higher level. And so we just kind of keep going through that cycle higher and higher until actually that reminds me that Bach has a piece where it's some sort of like praise to the king, and he basically keeps doing key transpositions so that it's a key change. But because the key transpositions are circular, it just seems like it keeps going higher and higher. And so as the key transpose goes higher, so does the glory to the king or something like that. It's kind of like a musical trick that he did. And so we're in some sense that we're doing the same thing.
I like this. I like this. So I think that we've covered a lot of ground, and it's really hard to put our finger on like what is the ultimate goal. But allow me to be a little bit poetic here. So basically, this idea is that you have this functional core, like whatever we can understand and wrap our heads around as reducible complexity, you should as quickly as possible wrap this up with functional programming constructs so that it's easy to understand, it's predictable in its nature. And then you should level up to the next level of abstraction where maybe you're back in the imperative land. And so if you keep doing this iteratively and like increasingly, you can basically propel yourself to managing more and more complex levels of a state rather than concerning yourself with the minutia of the simple things.
You know, Alan Kay goes one further. Like what he advocates is for a specific problem domain and level, you got to invent an entire programming language for that problem so that you can build another like the higher level domain on top of it and build another programming language for that. And it only takes like 2 or 3 to come up with something, like 2 or 3 layers of this before you come up with something that can be powerfully expressive and do real work. And so
interesting.
We can talk about that some other time, because I feel like Alan Kay, he has some good ideas, but his presentation skills are not very good. Like he really needs to hire a professional designer to do his slides for him.
We should definitely do an episode on Alan Kay, or at least some of the important work he did. You know, but yeah, I think even Lisp has this idea in terms of its macro system,
right? The
of
macro system.
like, you know, you basically should make a domain specific language to solve a particular scope of problem, and then you use that domain specific language in the next level of abstraction. And
Right.
so
In the ideal case, in practice, I hear some people like, oh, we built it, we didn't like it, so we backed it out, and we always use the escape hatch. But in terms of optimism here, like I want to say that it's the ideally we're able to reduce the complexity with some of these tools that we have, because we can't readily just skip to the next level in the domain. Like if we're down like worrying about like rendering loops and stuff like that, there's no way that we can like worry about like the grid layout for designers and stuff like that, right? And so we have to have some sort of bridge, and the functional is one of the tools that we can use to get there. But sorry, what were you going to say?
I was going to say functional programming allows you to build yourself a stairway to heaven, and you climb slowly and slowly and slowly to the pinnacle until you reach heaven, and you're able to build a system that is of God.
Yeah. I'm not sure where to go from there. So I guess that is, I guess, where our conversations have lift off, and optimism is, like you said, to the stars. So I guess unless you have anything else, I don't really have any.
I'm already on my way to nirvana using functional programming. So
or to bed, right? So because it's getting late.
Yeah.
All right. This is Will.
And this is Sri.
And we will talk to you next time. If you like what you hear, share, like, subscribe to our podcast or YouTube channel, and we will see you next week with another episode of the Technium. See you later.
Later.
Bye-bye.